Hi. So in today's video, I'm going to review what a log is and how you will be using it to solve problems. So a log function basically undoes the exponent, and an exponent undoes a log. So to just explain what the different parts are, so we have the answer to the exponent, we have the base of the exponent, and we have the exponent itself. So if I were to rewrite this as a logarithm, I would have the exact same base, so a base of 3 and an exponent of 3, and then the answer to the log would be the answer, sorry, the argument of the log would be the answer to the exponent. So let's see what this looks like as a logarithm. So a log base 3, then the argument is 27, and that equals the exponent, which is 3. So 3 raised to the power of 3 is equal to 27 in a log. Now, what this will do for you is you'll be able to solve problems when you don't know what the exponent is. So let's look over here and convert this to a log, just like we did, only this time the exponent will be what we will be solving for. So this is log base 3. The argument of the log is 27 equals, this time we don't know what the exponent is. So we're going to solve for that exponent. And because a log base 3 of 27 is an actual number, we can go to the calculator now to solve that. So let's turn my calculator on. And to use log, I can click right here if it is a log base 10. If I am not using log base 10, let's see if I can get this to get in the light the right way. If it's not log base 10, then I will need to convert to log base 10. Let's see if I can clear this. All right, so I need to hit math, and then I need to scroll down to log base. There you can see it. And then hit enter. And now it will allow me to change the log to base 3. So log base 3, and then hit the arrow key. And now I can enter my argument, which is 27, and then hit enter. And that will give me the answer to the log problem as a 3. So x equals 3. So let's try another one. So if we did not know what power we raised 25 to get 625, we could set up a log and then use our calculator. So this is log base 25. The answer to the exponent is 625, or the argument of the log, and that equals x. So now we can use our calculator to solve for that. So I have to hit math and scroll down. I could probably enter an A, but I haven't checked how to do that, so I'll have to check that and then get back with you. So log base 25, enter 625, and then you can do other math in here, but then you would end your parentheses. So then hit enter, and that answer, the exponent, is a 2. So x is equal to 2, which means if I take 25, the base, raise it to the power of 2, my exponent, I get an answer of 625. So let's take a look at how we would use this in one of our exponential problems from the workbook. So we know that this is number 25 on page 91. We know that Amy invests $6,234 in a savings account. So that is our initial amount, and that she has a fixed annual rate that is compounded continuously. After 7 years, the balance reaches $7,170.81. What is the interest rate for this account? So we know that the final amount is equal to 7,170.81. We do not know the R. That is what we're going to have to solve for. And we know that T is equal to 7 years. We will be using the continuously compounding formula, which includes E, the natural number E, and raised to the power of R times T. So let's just go ahead and fill in with what we know. So we know that A, the final amount, is 7,170.81. That is going to be equal to the principal, which is 6,234, times E, raised to the power of R times T. Oops, sorry, T is 7. So I need to change that to a 7. Apologize. So R is what I have to solve for. And when I am needing to solve for an exponent, I need to convert my problem to a log problem. However, I do need to isolate all of E before I can set up my log. So I need to use algebra to isolate this term. So seeing here that this is multiplication, I want to do the opposite, which is divide. So I will be dividing both sides by 6,234. And then I will have 7170.81 divided by 6,234 is equal to E to the power of R times 7. So now I can convert this to a log. When I'm doing logs of the natural number E, I will use a natural log, which is ln. That is a log in base E. I don't have to write the E as a subscript. So log base, and here's the answer to the exponent problem. So I'm just going to enter it right like this without doing any calculations yet. I'll just keep, I just need to enter that in, and then that is going to be equal to the exponent, R times 7. Be sure you don't rewrite the E on this side because the E is now here in the logarithm. But R is not isolated. So I do need to do one more step of algebra, and that would be to divide both sides by 7 to isolate the R. So I'm going to divide by 7. And now these will, of course, create a 1. So that's just one R, which is R. And this, all of this, is what I will enter into my calculator. Ready for the calculator. So natural log is a button on the calculator. You just have to hit that button. And then I'm going to type in 7170.81 divided by 6,234. Now at this point, it's important to close your parentheses to let the calculator know that you're done entering numbers into the logarithm. Now we can take that whole number and divide it by 7. So divide by 7 and enter, which gives us a decimal. Well, that makes sense because I'm looking for a rate. So if I take this decimal, 0.02, and multiply it by 100, that would give me my percentage. So the rate is 0.02, and as a percentage would be 2%, which makes sense. Now you could go back to your original equation and plug in the 0.2 and do this side of the equation only to see if you get 7170. So let's go ahead and do that. So 6234 times, and now we're going to use E. So I hit second ln. It brings me to the exponent position there. And so I can type in parentheses of 0.02 times 7, and your parentheses, and then hit enter. And that brings us back to the 7170.81. If I round, then I would get 0.81. Great. Let me know if you have any questions, and thanks for watching this video.